Good afternoon and welcome to the Akamai Connector for Varnish webinar. I'm Jeff Costa, the product manager for the connector on the Akamai side. So a few housekeeping notes before we get started. You'll notice that there is a Q&A widget that you can enter questions into. Please go ahead and do that as we go through the presentation. We will have time allocated at the end to be able to address those questions. We will also be recording the webinar today so that you can play it back later. And of course, we'll make the slides available for downloading. So today, your presenters are the following people: Colin Bendel, who is the director of the CTO office at Akamai; Dag Finstad, who is a senior developer at Varnish Software; and Davey Shafik, who is a developer evangelist at Akamai. Colin, over to you.
Awesome. So we're going to go through three sections today. We're going to talk a little bit about performance and the role of caching and the challenges that lay inside of that. We're going to transition to talking about the connector, what it does, how to install it, how to use it, and then finally into a bunch of advanced use cases. As we get going into this is a part of Akamai's broader vision around how we can help you in your different roles into the DevOps community to ultimately help reduce the efforts that you need to spend day to day to make sure your systems are online, operational, that you've got the best user experience. And then we realize that it's very complicated and often there's a lot of competing pressures. And so this is one of these aspects, and I invite you to visit developerakamai.com to learn more about some of our other strategies. So today, I'm really excited to talk about the connector, the Akamai Connector for Varnish. The connector itself is focused around bringing a lot of added value between the work that you're putting in at your origin, adding Varnish, and providing a lot of rich functionality through your dev and QA and into your production environments, and marrying that with Akamai. And we're going to dig into some of these features later on, but I wanted to highlight that there's a lot of aspects to this, and there's a lot more that you'll see as we get through this. Let's talk about the role of performance in caching. And we all realize at the end of the day that performance is an important part of that user experience. That users are coming from accessing your sites, accessing your products, interacting with your tools predominantly via mobile environments, mobile laptops, whether it's iPads or even phones. And the experience on the mobile environments is often very variable because there's a lot of competing pressures. And when we get complaints about performance, we start to dig into perhaps, what's the flow? How does a page build itself? And if you're familiar with a web page test, you might be familiar with these kind of film strip views where you see the page composed, and you realize that there's a lot that goes on in assembling a page. That when you're pulling up that page on your iPhone, there's a lot of different resources from JavaScript, CSS, images, and each of those play into ultimately generating that final user experience. And so where do you start? How do you compose that? Now, if you're probably very familiar yourself, having looked at the histogram of user experiences. And a histogram usually looks at the bins of how many people took to load the page at different time intervals. And here's an example where you see that there's a locus of people that experience the web page in 4 seconds, 4 or 5 seconds. But as the tail goes further to the right, there's less people that took 48 seconds, for instance, to load. But each person has a different experience. And it's what makes those differences is what will make and break your brand. There's been a number of research out there looking at performance, looking at what is the right performance, because the people on the far left, if a page comes in really fast, they're not the ones that are going to complain. The people on the far right are going to complain. But if it's the same page, well, how can it be so different? And the strategies that we use are often about how do we move the majority of people to get a much faster experience. In fact, Not only do users expect performance, but we've done a number of different studies, as many other companies have, and what we've realized is that there's a magic number around the 1.5 to 2 second mark, that if a user doesn't get the web experience, doesn't get that news, doesn't get the interaction that they're expecting, the user is going to be quickly distracted and move on and do other things. That conversion rates, whether it's going through a checkout process, whether it's consuming more pages, that conversion process is directly tied to how fast the page is. A user only has so much time when they're during their break, or when they're checking out what they're going to buy mom for Christmas, or that time is limited. And if you don't get that content to the user, they're going to move away. But we also have the challenge of we test in our local environments and we think it's really fast because, my laptop is really fast, I'm on a good Wi-Fi network. And it's easy to forget that the users that we are servicing often have very different mobile device hardware. Less than, 25% of new Android phones have less than half a gig of RAM that are being purchased this year alone, compared to my fancy new S8 that might have 3 gigs of RAM. There's a variable experience for those users, and so it's easy to forget that not everybody has the same experience. Now, if you're interested in the performance and how it ties to business metrics, because that's ultimately how we're going to convince our management teams to allow us to focus on bringing more performance. There's a great site, WPO Stats. I'd highly recommend you take a look at it. There's regularly updated with new research that shows how increasing performance for end users actually makes sense for the business, helps drive top line, as well as the general perception of a brand. Now, when we're looking at performance, there's a number of different strategies that we have built in the community. We have broken it down into 4 big groups. How do I reduce the wait time, that is to get those bits across the wire to the user? How do I spend less bits to create that web experience? Sending less bits, even on a slow connection, is better. How do I reduce the number of requests? And ultimately, how do I speed up the rendering? Once I get the bits delivered to the user, how do I speed it up into the composition? Now, all of these strategies all work together. And you'll notice that the first one at the top of our list is caching. And that's one of the best uses of improving that user experience. Because when we look at that waterfall, the first thing that sticks out is how long did it take to get those bits across the wire from point A to point B, from your application servers, through the internet, through the cellular infrastructure, from the cell tower to that device. So let's talk about caching. Now, caching is one of those parts of computer science that is so baked into everything that we do. Just consider your own device. You're watching this on your laptop or on your phone right now, and there is caching all the way down from the processor through to disk, through to the network. And just that reason for caching is because it ultimately increases performance. Just consider your processor. If a request hits L1 cache, that's going to happen in 0.0005 microseconds. But compare that to a RAM request. So as you move from L1 to L2 to L3 caches on the processor, if now instead that piece of work has to be requested to RAM, well, we're now looking at 0.1 microseconds. Well, you might think, oh, great, that's fast. But if I still don't have the necessary bits and I have to move on to disk, then it's getting slower. But just consider the RAM, for instance. Just a RAM hit is still 200 times slower than if I had an L1 cache hit on the processor. Once we move to disk, doing a seek might be 0.15 milliseconds. Access, but to do a full seek will take you 10 milliseconds to do that read and write operation. Well, we're already now, having not even left our disk, left our laptop, we're already at 20 million times slower than having that caching at the CPU. And so it's this realization that we also look at the network, and we realize that the time it takes for traffic to go across the network is way slower than that copper on your laptop. Wi-Fi, let's assume it's about 15 to 25 milliseconds. Once you get to cellular, best case, you're typically seeing about 75 milliseconds for LTE, 3G at 150 milliseconds. So you're looking at 300 million times slower than that L1 cache hit. And if you have to do any operations, like now actually going not just to your tower, but you have to transit across any part of the geography that the data center you're looking for is not inside the cellular tower, but they have to go across the ocean, go across the country. You can be looking at 1 billion times or 10 billion times slower than what it would have been for that L1 cache. So caching is incredibly important to help knock off the time in every piece of this access. Now, let's just do a quick refresh of what happens in a TCP connection, because this round trip is important. Typically for a single request to a web page, you're going to start with your DNS request. And at 50 milliseconds, just for that round trip, it's going to take DNS to go up and come back down, so 100 milliseconds. Likewise with TCP, just to do the TCP handshake, you got the SIG, SIGAC, and the ACK going up, down, up. Then to do the TLS negotiations, you're adding another 2 round trips. And then finally, at layer 7, you can make your HTTP request. So all of this combined, you're looking at 400 milliseconds before you even make a request to the server, before you even make a request to have to transit the internet or make server CPU time to compose that page or that response. So this is why caching at every level is incredibly important. Now, most people start to deploy their apps. You run through this experience and say, well, I'm going to have my phone. I'm going to assume a best case here at, say, 50 milliseconds to a tower. Let's assume for a second that there's no transit time. And there's a number of research that shows that the median, the P50 response time, time to first byte for most application servers sits at around 500 milliseconds. Now, that full time is going to be, for that user, just for that one request, is going to be the TCP connect time, the time to make the HTTP request, plus your server think time. So in this case here, just that round trip time, TCP handshake, back and forth, plus the request time to go up and down, plus the server think time, we're looking at just 1 full second for a request in this hypothetical experience. So this is where we first started off by looking into the real world, because the real world is not just one user, but hundreds, if not thousands, if not millions of users making that request. And they're making that request over the backhaul. And we're adding another 150 milliseconds in the backhaul, then going to your server and waiting. And this formula quickly takes what that theoretical 1 second brings it to, well, 1.7 seconds. But we all realize that this is still ideal because there's lots of other queues. Just talking on the cellular tower, the tower has to allocate time for every user to get their moment of time and creates a giant queue. And so if it's highly busy, people are going home on the subway, that queue gets longer and your performance just in that first hop gets longer and longer because you've got to wait in the queue to get your moment of time and reservation on the spectrum. And then your backhaul, another congestion point, and then your back-end servers. So that's why you build out big clusters of servers, of course. But that can easily, that 1 second to 1.5 seconds can easily trip up to 2.5 seconds with a lot of volume of traffic. Now this is where caching definitely comes in play, where you can now turn off a bunch of back-end servers, cache that content, so it will be rapidly available for the user. And that's usually the first step, and that's where you start with your Varnish layer. You add that layer of caching that shields your back-end and create a ton of great performance for the user. So now the users they still have the transit time, and we've chopped that 1.7 seconds just to 1.2, just because we don't have the think time, we don't have to worry about the clustering environment, the slowness of the back end. But we still have to think about all of those requests. Now if I go to HTTP Archive, it's a great resource to look at what's the trends on the web and how different content is being used. We see that an average web page takes between 50 and 75 web requests. So if we had to do this TCP handshake once and then make a 75 HTTP request time and you had think time, you'd be looking at a very slow experience. That is 30 seconds just to load a page.
That's not acceptable for that end user who's expecting the full page to be rendered in 1 second, 1.5 seconds. So in our theoretical model here, what you typically do is you would add, Akamai or at the edge, because we sit in those data centers inside of those ISPs, and we're able to deliver that content as close to the user as possible. And so in this environment, this is where you typically start to see layers of caching between having Varnish at your back end, shielding your back end infrastructure, and Akamai sitting in front. So we're able to take that many users coming in and eliminate a lot of that backhaul time and provide huge offload both in the infrastructure and give that user experience down now to each HTTP request at hundreds of milliseconds each rather than that full second. So that's the theoretical model. And that's the world that we want to get to, because Akamai sees the world. We've got a lot of traffic from a lot of different players, all the users, and we're sitting as close to the end user as possible. And we want to help provide that best user experience to your backend infrastructure and complement the caching layers that you've put in place. So I want to kind of talk about some of our experiences with this, and I want to highlight some of the work that we've done with the Canadian Broadcasting Corp. This is where we started our journey with looking at this Varnish connector. We've worked with the CBC on many occasions throughout the years for different sporting events, from FIFA to the elections. And in every one of these situations, we're designing it to help build the best user experience and ultimately serve these events. Now, when I started working with them a number of years ago, we had this particular challenge where the business requires a very fresh site because, of course, in sporting events, even news articles, it's all about fresh content. You can't have stale content, stuff that's too old. Users will notice, and it's not good for the business or the brand. And so when we started this conversation, they were getting offload from Akamai as well as their back-end Varnish infrastructure, but it wasn't as ideal as they would like. And when we started looking at this, how can we better synchronize these caching layers to get a much better experience? Because that 30-second TTL is still impacting end users. You're getting offload, but you could do better. And through a bunch of hard work, we achieved some great results. In this example, you can see this is the origin traffic. So the origin-bound traffic went very quiet. Once we started coordinating the caches between the Varnish layer and the Akamai layer, we were able to reduce that origin traffic substantially, even during high peak events that happened later on in that month, which dwarfed the original peak volume requests. So with a coordinated caches, we saw some great results in the back end, but we also saw some great results for the end user. Not only was the user getting that content from the cache at the edge, but it's also impacting the end user experience positively. That the user saw the page drop from the median page load time of around 3 seconds down to below 2 seconds. And that's a substantial impact for the end user. And that's why we saw this great value in coordinating these caching infrastructures to ultimately improve that end user experience. We were doing good before, and now we're doing better. So taking this lessons that we learned from this experience, we went to Varnish Software, and we built together the connector, the Akamai Connector for Varnish. And this connector not only allows you to coordinate your caching infrastructure, but also we brought in a ton of other features to help you with synchronizing purges so that your application infrastructure can be designed around the tools that you're familiar with your Varnish layer, and know with confidence that that is being replicated out into Akamai. And we're acting as the amplifier to what you've defined and decided and designed inside of your Varnish layer. Likewise, with your caching rules and caching policies, magnifying that out with Akamai automatically, taking your rules that you've defined in your VCL. ESI, deferring the ESI to execute at the edge, as well as providing the device characteristics that we provide, bring that back into your infrastructure. And there's a number of other features around best practices that are often missed particularly as teams change and move on. And this connector also ensures that those best practices are retained and just preserved, ensuring that the best experience between the interop of your Varnish layer and Akamai are created consistently. Now, at a high level, and Doug's going to kind of walk us through setting up and working through the different scenarios, but at a high level, what this connector is doing is it's interfacing two parts. One is interfacing directly to the Akamai Edge and providing the right instructions to how to deliver that user experience. And at the same time, also communicating within our cache control utility, so for purge and infrastructure, to coordinate the replication of purges throughout. But at the end of the day, the goal is to allow you to focus on the environment that you're familiar with, your Varnish layer, and let the connector act as an amplifier. I'm going to turn it over to Dag now. He's going to walk you through the setup and installation of the connector.
Thank you, Colin. So now that you've seen some of the advantages of having your cache layers coordinated, you will now, of course, want to install this thing. So in the next few slides, I will take you through the steps involved in installing and configuring the Akamai Connector. So we support both Varnish Plus and Varnish Cache open source versions 4.0 and later. So step one in this thing is, of course, to obtain the software. So you can do that by visiting the URL that was posted on the first slide. We will also repeat that at the last slide. It is akamaidev.io/varnish-connector. So if you are using Varnish Cache open source, you will be installing from a source tarball. And if you are using Varnish Plus, you will get access to a package repository. So in this demo, we are using Varnish Plus on a Red Hat-based system. So first, we grab the provided repo details, and we copy that into the correct place. Then we trigger a metadata refresh. And following that, we install the connector by doing yum install Varnish plus Akamai Connector. So if you are on a Debian-based system, it would be very similar. You just use apt instead of yum. So once the software is installed, we need to make a few minor changes to hook it up in your VCL. So the package installs a script which is called Akamai Connector Setup sh. So this will figure out your VCL directory, and it will install a couple of files in there along with a configuration file. So here, when you just run it, you will see the help text, which is the default, and you will see that there is an install argument there. And for automated setup, we run it with the install argument. So it should look something like on this slide. And we notice that the files are installed in the expected directories. So next up, we need to make a few edits to our VCL configuration. So in a typical setup, that file is etc varnish default VCL. So we open that up in an editor, and we need to add import statements for the Akamai vmod, and we need to include the Akamai auto VCL file. You may also need to import the std vmod if you didn't already have that in your configuration. So the included Akamai auto VCL, that is the file that takes care of automatically hooking into the request and response logic and hooking that into the appropriate VCL subroutines. So with that, with just those 2-3 lines, the VCL is pretty much fully configured. So after we've made the changes to the VCL, we need to load the new configuration. So we do that by doing a system control reload varnish. So with that, we should be up and running. So at this point, if you made an error in the VCL while editing it, it will throw an error message at you, and you will see what you need to correct in order to fix it. So next up, we'd like to verify that the connector is actually working. So to test it, we generate a request with a via header that corresponds to those that are sent by Akamai in their origin requests. So in this example, we use HTTP, but you can use curl or whatever you prefer. So we use this special URL, which is /akamai/testobject.html. So this is actually the Akamai shore root test object, which is generated synthetically from Varnish. So this request will not actually hit your backend server. So we run this, and we verify that we get a 200 response code back, and we also verify that the VIA header looks like this. It should say Akamai Connector in there. So another neat feature of the Akamai Connector is, as Colin mentioned, that we also synchronize purges. So when you do a purge on your local Varnish instance, the connector will actually automatically make sure that purge also happens at the Akamai edge layer. So you may already have purges configured in your VCL, but if you don't, you need to set that up in VCL receive. So you do something like this, where you check if the request method is a purge, and if so, you do a return purge. So in order to forward a purge to Akamai, the connector uses the CCU API. So in order to set it up, you must first make sure you have proper API credentials for that. So if you don't already have that, you should visit this URL and get it sorted. So once you have your credentials, you edit the Akamai Connector configuration file, which should be installed in /etc/Akamai Connector conf. There will be a few fields there that you need to set. So specifically, you need to set these 4 fields to match your CCU API credentials. So that is purge host, purge client token, purge client secret, and purge access token. So again, after setting that up, the Akamai vmod will read the configuration file, and on a system control reload, it should be up and running. So we can now finally test this by issuing a purge request to our local Varnish instance. So notice I issue it towards localhost here and not the DNS name of the site, just to make sure that we hit the Varnish server and not the server that is the DNS name of the site. So then I also need to include a host header, and I use the purge request method. So if everything went okay, what you will see here is that Varnish will propagate the response body that we get back from the CCU API, which is a JSON object. So if everything went okay, you will see a text with something like this, that it should say request accepted and 201. So if something went wrong here, like for example, the credentials were wrong, the error will be detailed in this response body. So you should be able to figure it out from that. Okay, so I'll now hand it over to Davey, who will talk about some of the more advanced use cases.
Thank you, Dag. So we're going to go through 2 use cases. So now that you have the connector up and running, these are 2 use cases that we've identified that we think are pretty neat and enable you to do some really exciting things. So, excuse me. So the first use case that we're going to be talking about is what we call hold till told. And what this does is it enables you to maximize origin offload while still maintaining a real-time experience for your users. So in this use case, we're going to be looking at a sports event. So trying to make sure that our users are getting completely updated scores while maximizing the offload. And we're going to do this using Akamai's new fast purge. And what this does is it allows you to purge content from the edge in 5 seconds or less. Excuse me. So what this allows you to do is it allows you to set minimal TTLs downstream so that your users can refresh their content very, very quickly, while at the same time maintaining a cached object at the edge until you have an update. So this is our very simple API. It just responds with a JSON object that holds the current score. And essentially what we want to do is we want to cache this at the edge forever until it changes. And so we have an explicit change request that happens through the Purge API. So with the API, changes happen pretty infrequently. So we see as little as 1 minute between updates, because obviously this is a sports game. This is something that's happening in real life and takes real time. But those changes may also be as much as 2 hours. So clients must receive those updates in as near real time as possible. And normally we'd have to avoid caching at the edge to make this happen. But with Hold Till Told and the Varnish connector, we can now cache at the edge between updates for maximum offload and performance. So what you're seeing here is the old use case where we could not cache it, or we had to cache for very short amounts of time, so that we got those real-time updates. So essentially the orange line represents the time where we're able to cache it. So you might set a TTL for 5 seconds. So every 5 seconds what we're seeing is requests back through to origin to update that, even if there are no actual updates, and that's represented by the green line here. With hold till told, what we can do is we can actually set the edge TTL to a much higher value. So that could be days or months even. And then we purge every time we have an update. And only then do we see a request back to origin to update that data. And then your user will get that request. And what happens then is the user is continually refreshing because they have a low TTL. So they're just hitting the edge rather than that going through to origin until there is actually an update. So what this might look like is, here's our VCL again. We're again in the default VCL. And we set the edge TTL by setting the berest.ttl. And here we're setting it to 365 days. You could also set it to an hour or 2 or 24 hours. And then we set the downstream TTL. And we do this by simply setting the standard cache control header. So set berest.http.cache control. And here we're setting a max age of 5. And so what that means is that on the browser side, they will only cache for 5 seconds, and then they will attempt to update that object. And they will only be hitting the edge up until there are new updates to that object. So the way that we test this and make sure that this is propagating correctly is we issue a regular GET request to our Varnish instance. And you'll notice here that we send an edge control header. So in this case, we're sending max age of 24 hours, which is the edge TTL, and then a downstream TTL of 5 seconds. And then if we go ahead and hit the edge site, again using a simple GET request, what we'll see here is just that propagated cache control with a max age of 5. Now, the second use case that we're going to look at is grace TTLs and pre-freshing. So this is something that we've identified that a number of our customers have run into issues with the disconnect between Varnish's grace period and Akamai's pre-freshing capabilities. And so just to kind of put a little bit of context around these, these are two great features supported by each of these products that enable you to ensure that your users do get a great experience by making sure they get a cached object, even if it's currently being updated. And they work slightly differently. And Akamai will do a pre-fresh. So what we'll do is towards the end of the TTL of that cached object, we will make a request through to origin ahead of time to try and update that object before the end users do. Whereas Varnish will do that slightly differently, where after the TTL has expired, they have a grace period during which the object can be sent to the user stale, potentially, while they're refreshing in the background. So essentially, anytime that you have a cache miss, this is you do not get the benefits of offloading the traffic. You don't get the benefits of caching. And your user's request potentially has to travel the distance through the internet to origin with potential congestion points along the way. This also adds more burden to your origin infrastructure. So particularly with cloud providers, more CPU usage, more CPU cycles directly relates to dollars spent. So any time that you get the opportunity to offload that, whether at the Varnish level or at the edge, is a benefit. So if we are, for example, setting 5-minute TTLs, what we'll see is that if we don't turn on this feature and we don't synchronize these features, we don't have this async refresh, what will happen is at the end of the 5-minute TTL, your users will start to go directly through to origin. And so in this case, we have 4 requests coming in during that short period where we haven't managed to repopulate the cache, and those particular users are getting a degraded experience. They're getting sent all the way through to origin, and they're doing the work of populating our cache for us. Of course, once the cache is populated, then we go back to the great performance benefits that we have. Now, this isn't as big a deal with longer TTLs. So with a TTL of a week or a month, you're getting a few users in a very short amount of time that are getting a slightly degraded experience. But as those TTLs get shorter, particularly as we do things like the hold till told with the live type experience, you spend more time refreshing the cache proportionate to the duration of the caching. So the more live that you want your site, the less benefit you can have from offload traditionally. So the way that Akamai and Varnish handle this is that, as I mentioned, Akamai will attempt to pre-fresh from origin. So prior to the TTL expiring, we'll actually try to hit origin and refresh in the background, while Varnish will continue to serve stale during that grace period if it's enabled. And this ensures that users get the performance of a cached resource with the obvious potential that they might get stale content. The problem is that when you do combine those two approaches, it becomes more likely that the edge will hit the stale version being served during that grace period. And of course, that's not the intended effect. So to avoid that, in Varnish, to turn on the grace period, it's really simple. You just set BERESP dot grace to whatever period that you like. So in this case, we've set it to a 30-second grace period. So this is the standard way that you turn on the grace period. And the connector will then ensure that the grace period is communicated to the edge. And essentially by communicating that grace period, we can ensure that the edge is able to pre-fresh and cache the most up-to-date version from origin as possible. So we're just ensuring that both Akamai and Varnish are in sync, and we're less likely to hit that stale cache being served during the grace period. So these are just two use cases, and they're really just scratching the surface of what the connector is currently capable of enabling. Colin already mentioned, we've seen this a couple times now, but there are definitely some really great features that we haven't been able to touch on today. For example, device characteristic handling. So we will automatically parse and make available device characteristic information within VCL so that you can make decisions in your VCL based on that. As well as things like deferring ESI processing. So rather than doing the work at Varnish, we'll defer that up to the distributed edge. So as a quick recap, Colin walked us through some performance and caching information to set the stage as for why we think Varnish is a valuable addition to your origin infrastructure if you're not using it already, as well as demonstrating the potential benefits of using Varnish with the connector behind Akamai, so why we built this tool. Next, Dag walked you through the installation process and how the connector functions, which is really, really simple. And then I covered these two advanced use cases. So hold till told for real-time updates with maximum offload, and synchronized async refresh by coordinating between the Varnish grace period and the edge. Now, everything you've seen today is really just the start. We're continuing to work closely with Varnish to improve and enhance the connector. So look for more features and updates over the coming months. And also, as a reminder, Varnish is just one piece of our larger Akamai for DevOps initiative. So I highly recommend that you check that out as well. So at this point, I'm going to hand it back over to Jeff, and we'll start the Q&A. Thank you.
Okay. Thanks, Davey. That was great. And thanks, Colin. And thanks, Dag. So we have a few questions in the Q&A. If you have a question that you haven't asked, please go ahead and enter that now, but we will go in order here. So I believe the first question goes to Colin. It's from Shamsi from Palo Alto Networks. And I think what he's asking for is the 2-second for what, upload or download speed? And I think what Colin was talking about here was download speed. Is that right, Colin?
Yeah, absolutely. Well, so this is the total experience. So if you're using a measurement tool, particularly a real user measuring tool, so like using Impulse or Boomerang or any of the tools that are out there to measure that end user experience, the research that's out there shows that if that full experience doesn't show up within 2 seconds, and that means downloading all of the resources
executing the JavaScript, assembling displaying those images, that experience isn't there within 2 seconds. Our primitive brain starts to get quickly distracted. We don't complete the transaction. We don't click on the next link. We don't, there's all these things that we just start to do. And this research shows the correlation of performance and your business benefits. And I mentioned, go check out WPO Stats for a good compilation. We just published a few weeks ago our State of the Commerce, which is a lot of research that we publish around how commerce platforms are impacted by performance and the stats around that.
Great. Thanks, Colin. The next question is also from Sham, and he's asking if there is an additional license fee to use the Varnish connector. The answer to that is no. This is a free product provided by Akamai, and you are welcome to use it as you see fit. The third question is from Martin Briest from Spreadshirt AG. And Martin's question is, will purging also work with Varnish's XKey purge in combination with Akamai's purge by cache tag feature in the future?
Yeah, I'll take that. And that is top of the list of our next iteration here to make, as we emerge out of our the beta cycle for Akamai's purge by tag and our cache key support, and making sure that works further with the connector. So stay tuned.
And Martin, to be clear, that the connector does not currently work with XKey purges, but as you heard from Colin, it is certainly something on our roadmap. Next question is from Frank Garnier, and the question is, does your connector compatible out of the box with Magento 2 VCL?
Yes, so essentially it should be. There is a potential for conflicts, of course, anytime that you include other VCL. It should be noted that the VCL is just standard VCL, and so it's fairly small. It should be fairly easy to just extract that out and inject it correctly by hand as well. So if it is not currently compatible, it would not be a major task to integrate that.
Thank you very much. The next question comes from Nigel Peck, and he asks, regarding the syncing of the grace time and pre-fresh, when Akamai is pre-freshing a resource, won't it hit the grace cached objects? Second part of that question is, how is that taken care of?
Yeah, so on the most part, the goal of the systems is to handle that period of time so that at the same moment that the refresh is coming back to the Varnish layer, that it's picking up the content and making that available by the time that Akamai's pre-fresh kicks in. So there is this moment that, because the connector is in place, we're able to offset that time slightly. There are a few footnotes in here where there are some races, and they're definitely where we're expanding that features. But the objective is to ensure that both are refreshed at the same time.
Thank you, Colin. Our next question comes from Yang Bao, and his question is Varnish the glue layer between Edge and the origin server? So to answer that question, I'll start it, and Colin, if you could finish up behind me, please. Is that many of our customers, our joint customers, run Varnish at origin and Akamai at the edge. And this product is meant to be that glue layer between that origin Varnish layer and the edge server itself. That is correct.
Yep,
and
that's perfect.
Anything else there, Colin? And our
last I'll actually jump in there as well. Sorry, I think it's really important to point out that one of our goals here is to enable your developers who are effective and already working in Varnish to continue to do so and ensure that we're actually propagating those expectations when they make those changes up to the edge. So that's a major goal. It's also to sort of make Varnish more the source of truth. So if you're very familiar with that, and your developers are used to working in that, then they don't have to go outside that to affect change on the Akamai side.
And to add on to that, it's an acknowledgement that Akamai understands that you want to work in the environment they're most comfortable with, and often that is Varnish itself. And we're trying to provide you tools that allow you to do that where you want to work. Okay, I think we've covered most of the questions that are in the Q&A box. Any other questions before we close out the seminar? If not, thank you all for attending. Hopefully this was exceptionally valuable for you. If you have any follow-up questions, we're happy to answer those offline as well. You should be receiving a notification where you can download the deck itself if you want to review it or review the entire presentation. Thanks again for your time. And thanks to all of our presenters.